Alright, in this video we're going to be talking about how to graph lines from slope-intercept form. So just a reminder that slope-intercept is y equals mx plus b. So we just have a short little flow map here that gives us 4 steps. So to graph a line, the first thing you're going to do is you're going to identify the y-intercept. Now remember that y-intercept is the b value, and you're going to plot that y-intercept on the y-axis. Once you've plotted the y-intercept on the y-axis, you should have a single point. You're going to identify the slope, that's the m, and you're going to complete rise over run from that y-intercept. You are not going to go back to the origin. That is probably the most common mistake I see happening, is when students do rise over run, they go back to the origin. Wherever you do rise over run, you have to start from that y-intercept. All right, and after you do the rise over run, you're going to plot a new point. And now that you have 2 points, you can connect those points and form a line. Now, just a reminder about rise over run. So rise is going to be your up or down. You're going to go up if your number is positive. You're going to go down if your number is negative in the numerator. Your run is the number in the denominator, and that's your left or right. So you're going to go to the left if it's negative, to the right if it's positive. So we're going to do a few examples, and you're going to do some on your own and actually review those examples after I'm done. All right, so they want us to graph y equals negative 4x plus 3. So I've got the little flow map below here, but the first thing that we're going to do is we're going to identify our y-intercept. So our y-intercept in this problem is my b value. So just a reminder, y equals mx plus b. So my y-intercept here is going to be 3. So that means that I'm going to go plot my y-intercept on the y-axis. So I'm going to go to positive 3 and I'm going to plot that point. Now we need to identify the slope. So my slope is my m, that's negative 4. But in order to do rise over run, you have to have a denominator. So if I have a whole number, I have negative 4 here. In order to make it into a fraction, I'm going to put it over 1. You have to have a numerator and you have to have a denominator to do rise over run. So whenever you don't have a numerator and denominator, put it over 1. All right, so in the numerator, my 4 is negative, so therefore we're going to be going down 4 units because rise is up or down. And then my 1 is positive, so we're going to be going to the right 1 unit. So from that value, so I'm going to kind of show you this change. You're going to go from the y-intercept. So from there, we're going to go down 4 units. So down 4, so 1, 2, 3, 4, and to the right 1, and there's my new point. All right, we can do this multiple times because the change should be constant, so I can do that rate of change, or my slope, multiple times. I could go down 4, right 1. And that's going to create my line where I can now connect my pieces and graph my line. And also, when we're thinking about our slopes, this is a negative slope. So we read the graph from left to right, just like we read a book. And if we go from the left side to the right side, it's going down. So therefore, it is a negative slope, which we do in fact have a negative slope. So negative slope, it's going left to right, it's going down. All right, so in this example, same process, we're going to identify our y-intercept, and our y-intercept in this particular example is negative 1. So just a reminder, this is y equals mx plus b. All right, so we're going to go to the y-axis, and we're going to plot our point at negative 1. Now we're going to identify our slope. So our slope is 2 over 5. So my slope is going to tell me that I'm going to go up 2 units because it's positive, and to the right 5 units because it is, because it's also positive. All right, so I'm going to indicate that here. I'm going to go up 2 units and then to the right 5 units. And I now have a new point at 5. And I should be able to connect that line. I only have to have 2 points in order to make a line. However, you could do it multiple times if you wanted to. So go up 2 units and over 5. Okay? All right, and for this slope here, we have a graph. We're going to read it from left to right, just like we would read a book. So from left to right, I see my graph is going up, so it has a positive slope. So that positive slope, we do have a positive 2 over 5, so that does correlate. So positive 2 over 5, positive slope going up from left to right. All right, in the previous examples, they were already in slope-intercept form. They were in y equals mx plus b. In this example, it is not. This example is what we call standard form. Now, we are going to learn how to graph directly from standard form in a few lessons. However, today what we're going to do is we're going to actually convert this into slope-intercept form. Now, standard form is ax plus by equals c. It's where my x and y are on the same side, and it's equal to the constant. So we're going to turn this into slope-intercept form. So we want to turn it into y equals mx plus b in order to graph it. Okay? So to do that, we are going to solve for y. That is the reason we learned how to do literal equations in the first unit, so that when we had to do that here, it was already something we were aware of. So we have 2x plus 3y is equal to 6. And we're going to solve for y in order to get y by itself. All right, so we're going to do 2x, and we're going to subtract that on both sides. So that gives me 3y is equal to negative 2x plus 6. I put the x first just because the x comes first in the slope-intercept form. I'm going to divide by 3. And at that point, I want to simplify. I'm going to make this as easy as possible when I go to graph. So negative 2 divided by 3 and 6 divided by 3. So negative 2 divided by 3 is going to be negative 2 over 3x. 6 divided by 3 is going to be plus 2. So we are now going to be graphing this in slope-intercept form, since we have solved for y. All right, so we're going to start with this problem. We're going to start with our y-intercept. Our y-intercept is at 2. So we're going to plot at 2. And my slope is negative 2 over 3. Now, the most common mistake that I see students make is if there's a negative in front of the fraction, students will make it like this. They'll make it negative 2 over negative 3. And that's not correct. Negative 2 divided by negative 3 turns into positive 2 over 3. And that's not what we want. That's not what we're looking for. So my recommendation is whenever you have a negative, you always put the negative in the numerator. Okay? So that is going to make it so we have negative 2 over positive 3. And then I know that I'm going to go down 2 units, and I'm going to go to the right 3 units. All right, so from my y-intercept, I'm going to go down to right 3. I'm going to plot that new point. I can do it again if I want to. I'm going to go down to right 3. And I can make that equation of this line. A few things to also connect here is when we're talking about a positive slope or negative slope. When we read a graph from left to right, just like we read a book. So if I'm looking at my graph here, if I'm reading it from the left side to the right side, it's going down. It's going down because it has a negative slope, okay? If it has a positive slope, then it's going to go up from left to right. If it has a negative slope, it's going to go down from left to right. Just something to keep in mind to make sure you did it correctly. Now, the last thing I want to review is you can actually check your graphing in Desmos. So I've got the Desmos version pulled up here, and I'm going to simply type in my equation. So y equals negative 4x plus 3. Now, a couple of things that I want to check while we're looking at this is the y-intercept. So I can click the y-intercept and it'll give me the 0.03, which is what we got. And I can do my rise over my run. So the point that we had for when we did rise over run, when we went down 4 and right 1, was at the point 1, negative 1. So if I go to my graph, I should be able to see that at 1, negative 1, there is a clear point there. We also identified another point at negative 5, 2. So if I go down, or excuse me, to -5. So if I go and adjust that, I can see that I have 2, -5. Now, the other thing is when I'm doing this, I'm actually holding my finger down and sliding it on the graph just to check that out. And that does, in fact, match the graph that I got. Also, I have the next one, so I'm going to clear that out. I have y equals 2 over 5. Now, if I type x right now, the x is in the denominator, and that does not create a line. So we're going to delete that. We're going to hit this arrow that's in the bottom screen that's going to move my cursor out of the denominator to the right. And now we're going to type x minus 1. I see that my y-intercept, I clicked the y-intercept and it was at 0, -1. And we should have a point at 5, 1. So if I go to 5, 1, I can see at 5, 1 that clearly is a point there. I can also type the point 5, 1, and I can see that it lands on the graph. Okay, so these are just ways to check behind yourself. All right, the other problem that we had, now I'm going to do this both ways. I'm going to put it in standard form. And I can actually see my graph here. I can see that my y-intercept is at 2, and I can see that I have that value at 3, 0. I can also graph the one that I solved for, y equals -2 over 3. Make sure I get that cursor out of the denominator, x plus 2. And I should see the exact same graph. I mean, because it is the same line. If I click the color on the actual Desmos, I can see it turn off and on, that they're on top of each other. And again, that's just a way to check yourself with your graphing. I hope this helps.